Greetings, and welcome to another Aletheia Game Studios tutorial. My name is Clint Fleetwood, and today our tutorial is going to show you how to use a video stream from a website source to create a background that is a video in your game. Let me give you a little background on why I'm doing it and the reason why I'm doing it the way I'm doing this. I teach kids at my studio. I teach kids, that's what I do every day. And I have this semester a robotics class. And in the robotics class, we're going to try to make augmented reality robots. So what we're going to do is attach a camera to our little robots using a Raspberry Pi. And that camera is going to send a video feed. And that video feed will go to our tablets or our computers. And we need to have that in our game. So as we run the robot around or spin the robot around in the camera to see things in the real world, we want our game to interact with it. So like enemies coming flying around corners, and to do various things like that. Or if we're playing like a BattleBot type game, you could actually see the other players on the field, but like in the real grass and stuff, but it'll actually show explosions and that sort of thing. So we're really excited about it, and one of the hurdles we had to come over with was how to send the feed to Godot. And of course we wanted to use Godot because we love Godot. And so this is the solution I came up with. It may not be 100% perfect solution because obviously there's some flaws in my opinion, but it's the best I could come up with now. And I'd love your opinions on it when we're done to show you what's going on and any suggestions you guys may have. But either way, I wanted to share it with you guys. So what I have here is a very basic scene. If you don't know how to set up a scene in Godot, this is not a good tutorial to start with. Go find some tutorials about scenes that are being set up, and go from there. But it's a very basic scene. I have this little platform that I call land, which is just a test cube, and then I have the camera, which is very important, and then I have a quad, which is basically just a plane. In Blender, that would be not equivalent, but very similar to what a plane is when you make a mesh. And then two enemies. So one of the things that I have is this quad is under the camera. So when the camera spins, the quad spins with it. That's important. Not that way. When the camera spins, when the camera spins this way, the quad moves with it. And then on the quad, I have a very simple material that is a shader material, and it's about as simple as you can get. UV to UV in a texture uniform texture that I just named image, and then I take the RGB out of that to the diffuse, and it's just a fragment shader, and that's all you need to do for this setup. So when I run this, as you can see, I've got some enemies coming at me. There's other little test cubes, and there's ones right there. They don't really do anything yet, but you could set up collisions or whatever you want with the camera and see how it works. So when I spin the camera around, it spins the quad with me. Okay, so that's a really simple setup. Nothing special there. All right, so let's go to the part that makes this a little unique. We have to have a web server that serves JPEG images from a stream. Now, OpenCV does this really simply, and OpenCV is really good with Python, which is great for me because OpenCV and Python. I mean Python is great for the Pi. So the Raspberry Pi using Python, using OpenCV and sending that HTTP request. So that's the reason why I decided to make my web server in Python. You could also do this with Node.js, if you could do Node.js with OpenCV or some other video feed source, because it does work with Node as well, or any type of other web server that you use. But the main thing you need to look at is when you're sending the images, and this took me some time to make sure that was right, is the content link in the header is incredibly important. Now, if you don't know anything about setting up a web server, that's beyond the scope of this tutorial. I will share this Python script because it's pretty simple and it just works later on, and I'll put it up on the web on a Git later. So you could actually see this. I'm using Flask, which is a web server, a Python module. Makes this a whole lot easier. So you would probably, if you just don't copy what I do and just don't install Flask, you would need to go through the tutorials to learn how to use Flask. But simply what's happening is when a web server request asks for an image, it sends the image right here. It sends the image to the request. Down here, it actually starts the video. One of the things about web cameras is you can't just like take a picture and then send it. It needs to be going all the time and then grabs the picture that it's going all the time. Because if you try to take a picture, the delay will be too long because it has to turn on the camera and things like that. So I'm not going to explain this too well. It's pretty self-explanatory. And if you know anything about OpenCV and Flask, it just kind of works. So that's my web server. Like I said, you could use Node or whatever else you want to. And I'm going to just turn the web server on by doing Python camera server. My Logitech camera sends these errors out all the time on my server. I could ignore it and make it where it doesn't show that, but I'm just, for the sake of this tutorial, I'm leaving it up. So that means the light, and you can't see it, the light on my camera has just turned on. So if I play now, you'll see me, and I'm talking, and these 3D things are happening in real time while I'm talking. And, you know, if I did some kind of collision detection or image detection, you know, where I can grab that item or grab this item over here, my camera's backwards. I could do something along those lines, and it would work. So let me show you how we did that. Let me go ahead and show you this. So here's the script for my camera. It's pretty simple, and there's a couple things going on here. First of all, I do create an HTTP, and I do create a empty loader variable. That on isn't necessary anymore. It was in that directory isn't necessary anymore. And then I create a constant, which is a temp file. This usage of the HTTP request I actually got from another tutorial that I'll put down in the comment section of the video. So the input process, really easy. That's just me turning the camera back and forth. No real reason to worry about that. And so when we go down to here, we set the input process to true. That's the keyboard command. And then we create the get the node HTTP request, which is right here. And then we make it use threading, which is important, because if not, it would just make the speed really slow. It'd like stop and wait every time it tried to get a new image. And then we connect it when the request is done. We go to image downloaded. Request complete, signal is sent. We go to image downloaded. So, and then I have a function called get image. So we're going to look at get image. Get image is really simple. It sets the download file to, on is needed. It sets the downloaded file to on temp, which is basically either 1 or 2. It just keeps on going, and I do this because if you try to, I'll explain that in just a second. And then I send the request to that host, which was the same as my server. After that, it says okay and tries to download the image. If the results are okay and the response code is 200, then it creates this loader, and it loads interactive. And the loader, and the reason why I want to load interactive is because I don't want it to wait to load to, again, I don't want it to cause a delay. So then I set the process to true. All right, and so load interactive. Then we go up here for every single frame. If loader is true, because it's empty if it's not. If it's trying to load the HTTP request, it becomes empty. It becomes null. So if loader is true, and we're trying to see if the error end of file, because this is the error, checks and see if the loader's polling, and then if it's in the file. This is actually straight from the documentation on Godot, so I don't want to explain that too much. Anyway, so it says loader equals get. Loader means get resources, and then it sets the image to the resource, and then that runs that function. And then here's where we set the shader param image to that resource. Then it says if that file exists, go ahead and remove the previous file, so that way it doesn't load up all the images in that. and then it changes on, and then it runs it all again to get image. And that's how we basically get this to work. So it's pretty simple. One of the problems that you would have if you don't use the on, it would actually just load up the user cache with thousands and thousands and thousands of images, and that's not something you want. So I'll just go ahead and add the image and delete the image. I haven't found a way yet in Godot to take an image just from memory. It has to go download to a file. So if there's a way to do that, I would actually use an image from memory instead of saving it to file, and that would probably work better. Anyway, that's just basically what we got going on. I'll go into more detail as we progress and how to make edge detection and that sort of thing later on. I just wanted to share this really quickly. I'd love for any comments, concerns, gripes, grievances you have about this, and let me know what you think. All right, until next time.